It is compression.
Absolutely, it's compression, right? So we're pushing our particles closer together, right? They're not shrinking, they're not getting smaller, they're just getting closer together, all right? So great job with the do now. I'm glad that everybody was able to recall and was able to go back to their notes, which is perfect. And we're going to actually move into our lesson for today, all right? So before we do that, reminder, today is this day 2 of our 12 days of giving. I know we talked about the 12 days of giving yesterday, but for today, you're going to enter a raffle. You must earn 5 PBIS points in your PE or musicology class, all right? So in order to enter today's raffle, you have to get a 5 in either PE or musicology. And if you get a 5 in science, I might be able to see if I can get you an entry, but that's neither here nor there, all right? So for today's agenda, here's what we got planned for today. So we're gonna have our do now review, which we just did. We're gonna move into our weather and water intro. Okay, so we're gonna do the investigation 1.3 because we just finished 1.2. Then we're gonna do a little bit independent practice. We're gonna review that practice, and then we're gonna finish with a check for understanding. Okay. So is everybody good for what we got for today? All right. So here are the questions that we should be able to answer before today is over. All right, so I'm going to post these questions. I want you to put in the chat, what do you think they are, right? What do you think the answer to these questions are? All right, so the first one, Blake, can you read for me what that question is, please?
What is the atmosphere?
Exactly, right? So that's the overarching question. What is the atmosphere? What's in it? What is it made of? What does it consist of? So we're going to, by the end of today, you should be able to tell me what is the atmosphere, all right? The next thing we got to know is, Marcus, can you read that for me? What does that say?
It says gases. What gases make up the atmosphere?
Exactly. So we also want to know what gases make up the atmosphere. So not only do we want to know what it is, we want to know what gases make it up. And then the last question that we want to know, that we should know by the end of the day, is what layer of the atmosphere do you think is the greatest interest to meteorologists, and why do you think so? All right, so we're going to figure out why meteorologists are studying this specific layer of the atmosphere as we go through the different layers of the atmosphere. All right. So, quick review. Oh, that shouldn't be showing right now. But who can tell me what elements make up air? All right, so this was in our do now. What elements make up air? Go ahead and put that in the chat. Go ahead and flood the chat. What elements make up air?
Mama.
So right now we should be in the chat saying right now what elements make up air. We just answered it. We did it for our do now. Zamari, do you know what elements make up air? Thank you, Markel. It should be simple. Everybody should be blowing the chat up. We just answered it for our do now. We talked about the two most abundant ones, but then there's like one extra one that makes up the air. Thank you, Zakara. Right, so the air is made up of many tiny particles, which consist or are constantly in motion with a lot of space between them. Those gas particles include oxygen, which we talked about, 21%, nitrogen, which we talked about, with 78%, and then other variable gases make up that last 1%, right? So remember, we talked about a lot of different variable gases, ozone, methane, right? Those are variable gases. And this is the 1% that makes up our air, okay? And then our last question, which you also just answered, is when air particles are pushed into a plunger, is the air expanding or compressing? And are these particles getting closer together or smaller? All right? And we talked about that. Can I have Zamari, can you go ahead and tell me when air particles are being pushed in the plunger, remember we did the air and syringe experiment? Explain if they're expanding or compressing, and are they moving closer or are they getting smaller?
They are moving closer.
Mm-hmm. And what's happening? Are they expanding or compressing?
I think it's compressing.
Mm-hmm. Because compressing means what? It means when you're pushing things closer together, right?
Yeah.
Exactly. So we're gonna actually, now that we did our little review, we're actually gonna do a group reading. All right. So we're gonna do the thin blue veil reading, and it's gonna actually talk a little bit about what's going on in the Earth's atmosphere, so we can learn what's actually in there. Okay. So for today's reading, we're gonna learn about the Earth's atmosphere and what it's composed of. During this reading, you will take notes and follow along so you can complete your independent practice for today. All right. So in Google Classroom, we do have our independent practice assignment, and we also have the reading that you can follow along with, or you can follow along with me here and go back to refer to the reading as you get your 10 minutes of independent practice. Okay? So I'm going to go ahead and stop sharing real quick. And here, I just wanted to put it out here. Here's a phenomenal time to earn some of those PBIS points that we're talking about, because I'm going to popcorn read, okay? So we're going to read. I'm going to call you out. If you were there to read, you're going to earn yourself a point. If you're not, if you decline to read, it's going to be hard for you to earn that point, okay? Let me go ahead and... Marcus, you good? You can see it? We all good? Okay. So if you're trying to zoom in on your page, all you have to do is click the image, like we always say. You click the image and then you space your pad to zoom in. But you don't even have to look at that right now, because you can just look at it on the main screen, because I have it up here. Okay. All right, clear. All right. So thin blue veil, not too hot, not too cold, just the right temperature. Our atmosphere is essential for life on Earth to exist. It is cold, it is cold in deep space. The temperature in the neighborhood of negative 207 degrees Celsius. That's nearly 200 degrees Celsius colder than it has ever been on Earth. Near stars like the sun, it is terrifically hot, reaching thousands of degrees. But there are places here and there in the universe where the temperature is between the extremes. These areas where life can exist are sometimes called the Goldilocks zone. Earth is one of those places, and the average temperature on Earth is not too hot and not too cold, but just right for supporting life. All right. So could I have Miss Jalea Henley? Can you read that first paragraph for me?
On any day, the temperature range on Earth is about 100 degrees Celsius. It ranges from about 45 degrees Celsius in the hottest places to negative 555 degrees Celsius at one of the poles. The extremes are 57 degrees Celsius in Fahrenheit.
Thank you. And could I have...
Prince.
No, you're good. Thank you.
Huh?
You're good. Thank you. Zamaya, can you read that next paragraph for me, please? Where it starts off saying Creek Ranch.
Creek Ranch Death Valley National Park, California, recorded on October 7, 1919, and 87 degrees in Vostok, Antarctica on July 21st, 1983. So Earth's range of temperature is 146 Celsius. The frigid polar regions, the Arctic and the Arctic.
Thank you. So as you can see here, like the range of the weather, it can go from negative 189 degrees Celsius to over 146 degrees Celsius. That's or no, excuse me. Yeah, it can go from 57 degrees to negative 89, which is over 146 degrees range of temperature, right? Like that's a crazy range. Can you imagine being like I don't even know, brick cold to like being like you're sweating, melting hot? Like that's the different ranges of temperatures that we can have all over the world. All right. So we're gonna go into the atmosphere. Marcus, can you read that first paragraph for me when we talk about the atmosphere? You gotta unmute, sir.
It is only Earth's distance from the sun that affects the temperature. Earth's atmosphere keeps the temperature within a narrow range that is suitable for life. From space, Earth's atmosphere looks like a thin blue veil. Some people call it an ocean of air. The depth of this ocean is about 600 kilometers. The air is most dense right at the bottom, where it rests on its Earth's surface. The air gets thinner and thinner, less dense, as you move away from the Earth's surface until it disappears. Imagine a column of air that starts on Earth's surface and extends up 600 kilometers.
Keep going.
To the top of the atmosphere, scientists have discovered several layers in this column of air. Each layer has a different temperature.
Thank you. So, right, we're gonna learn about the different layers of the atmosphere, right? So there's the troposphere, there's the stratosphere, there's the mesosphere, the thermosphere, and then we have the exosphere. All right. We're gonna learn specifically about which each one of these are. So starting off with the troposphere, Deshaun, can you read that for me?
The layers of the atmosphere we live in is the troposphere.
Troposphere?
It starts at Earth's surface and accelerates
Dense.
up where 10 through 24 kilometers. It's
Thickness.
I can't see that.
Memoir.
Depends.
Its thickness
On
depends
the seasons where on the seasons and where you are on Earth over the warm
equator.
equator. The troposphere is the little thicker than it's over the polar regions where the air is colder. It's also thickening during the summer and things during the winter. A good average thickness for the troposphere is 15 kilometers. The bottom layer covers most of the organisms, dust and water vapor and clouds.
Found. Sean, you there? Okay, so most of the water vapor is found in the entire atmosphere. Thank you so much, Deshaun, if you can still hear me. It also contains most of the air. And most important, weather happens in the troposphere.
Actually is.
So hold on a second, Deshaun. So this is the most important part, right? So I want everybody to make sure this part goes in their notes. And the most important